Hi everyone. In this video, we are going to discuss about how to find the general solution of trigonometric equations which are kind of like this. Sine squared x equals sine squared alpha or cosine squared x equals cosine squared alpha. We have to see how we can find the general solution for this type of trigonometric equations. Now, before we go too far, one thing we need to understand that they both are actually same equation. Even though the look and feel is different, we can show that they both are nothing but the same equation. Now, how can we prove that? Let me first write down the equation with the sign ratio. Sine squared x equals sine squared alpha. Now, we are going to use the Pythagorean identity, which is sine squared x plus cosine squared x equals 1, or you can say sine squared theta plus cosine squared theta equals 1. So we are going to use that Pythagorean identity of trigonometric ratio in this particular situation here, right? So if we substitute sine squared x with cosine squared x, then actually from the Pythagorean identity we can say that sine squared x is equal to 1 minus cosine squared x, and that's the value I am going to use now in my original equation. In place of sine squared x, I am going to use 1 minus cosine squared x. So then what happens here? Well, in place of sine squared x, I am going to say 1 minus cosine squared x, and similarly in place of sine squared alpha, I am going to say 1 minus cosine squared alpha. And now you can see that we have a positive 1 on both sides, so they will cancel out each other, and then we are going to be left with negative cosine squared of x is equal to negative cosine squared of alpha, and if we multiply both sides by a negative 1, then it will become cosine squared of x is equal to cosine squared of alpha. So as you can see, it now changed into cosine squared of x equals cosine squared of alpha, which is actually in the second red box up there. So they both are nothing but the same equation. That means they both will have the same solution. So let me make a quick note here that they will have the same solution, and I'm going to erase this other note right here. Alright, so now even though they look like two different equations, but they're actually the same equation. So if we can solve just one of them, that will give us the general solution for both of them, right? And I'm going to erase this other portion here also on the left hand side. Let me erase this. Now let's see how we can come up with the general solution, right? So I'm going to start with the sine ratio. So sine squared of x is equal to sine squared of alpha, where of course alpha is a given angle. In the question, alpha will be a given angle, and we have to find the value of x in terms of alpha angle, right? So from here, can we write it as sine squared of x minus sine squared of alpha is equal to 0 if we bring everything to the left hand side. So this is looking like a difference of two squares. So if we factor them, it's going to look like this. Those will be the two factors. It's like a plus b times a minus b. That will give us a squared minus b squared. So now from here, we can say then each of the factors could be 0. Now from each of them, let's see what we get, and this can be written as sine of negative alpha, and then from the other one here, from the other factor, what we get? We get sine of x is equal to sine of alpha. Now in the previous video, we have seen that the general solution for sine of x equals sine of alpha is actually n times pi plus negative 1 raised to the power n times alpha. So let me write down the general solution here for these two equations. So for this first equation here, so here we can say, well then definitely x is equal to n times pi plus negative 1 raised to the power n times the angle, in this case negative alpha, and on the right hand side we can say that x will be equal to, for the other factor, there we get x equals n times pi plus negative 1 raised to the power n times the angle, which is alpha, in this case positive alpha. So for the first factor, alpha is negative, or the angle is a negative angle, which is negative alpha, and for the second factor, the angle is a positive angle, which is just alpha. Right? Now let's try to use different values of n and see what are the different values of x we are getting. So let's first use n equals 0. Then what would be x? Well, x would be equal to 0 plus negative 1 raised to the power 0 times negative alpha. So that would be 0 plus positive 1 times negative alpha. So that would be negative alpha. And on the other one here, if we use n equals 0, then we are going to get just a positive alpha. So here x will be positive alpha. Now let's use n equals 1, then what would be x here? For the first factor, x will be equal to pi plus negative 1 times negative alpha, so that would be pi plus positive alpha. And for the second factor here, for n equals 1, what would be x? Well, here x will be equal to pi plus negative 1 raised to the power 1 times alpha, so that would be pi minus alpha. Now let's use n equals 2, then x would be equal to 2 pi plus negative 1 square times negative alpha, so that would be 2 pi plus positive 1 times negative alpha, that will be 2 pi minus alpha. And then here on the right hand side, for n equals 2, x will be equal to 2 pi plus negative 1 square times alpha, so that would be 2 pi plus alpha. And if we take n equals 3, then x would be equal to 3 pi plus negative 1 cubed times negative alpha, so that would be 3 pi plus negative 1 times negative alpha, that would be 3 pi plus alpha. And on the right hand side, x will be equal to 3 pi plus negative 1 cubed times alpha, so that would be 3 pi minus alpha. Next, I am going to try a few negative values for n. Let's take n equals negative 1. Then x will be equal to negative pi plus negative 1 raised to the power negative 1 times negative alpha. So that will be negative pi plus negative 1 times negative alpha. So that would be negative pi plus alpha. And here again, if we use n equals negative 1, it will be negative pi plus negative 1 raised to the power negative 1 times alpha. That would be negative 1 times alpha. That would be negative pi minus alpha. And then let's use n equals negative 2, then x will be equal to negative 2 pi and then plus negative 1 raised to the power negative 2 times negative alpha, so that will be positive 1 times negative alpha, so that will be negative alpha then. And here on the right hand side, x will be equal to negative 2 pi and then negative 1 raised to the power negative 2, that will give us a positive 1, so positive 1 times alpha, that would be plus alpha then right here. And then if we use n equals negative 3, then x will be negative 3 pi and then negative 1 raised to the power negative 3, that will be a minus 1 times negative alpha, so that will be just positive alpha, so negative 3 pi plus alpha. And on the right hand side here, x will be equal to negative 3 pi when n equals negative 3, so negative 3 pi plus negative 1 raised to the power negative 3, that will give us a negative 1 times alpha, so that will be minus alpha. Now from here, as you can see, no matter what integer value of n we use, we are getting two possible values of x, which is n times pi plus or minus alpha. So when n equals 1, we get 1 times pi plus alpha and 1 times pi minus alpha. Similarly, when n equals 2, we get 2 times pi minus alpha on the left hand side and 2 times pi plus alpha on the right hand side. Again, when we use n equals 3, we get 3 times pi plus alpha on the left hand side and then 3 times pi minus alpha. And similarly for 0 also, we can say, well, this negative alpha is actually 0 times pi minus alpha, and here on the right hand side, the positive alpha is actually 0 times pi plus alpha. So in each case, we are seeing that the value is looking like n times pi plus or minus alpha when n is any integer. So the general solution here is like this: x will be equal to n pi plus or minus alpha where n is an integer. Also, there is another way of finding the solution. So let's now try to look at the second method. Let me first write down the original equation. If we bring everything to the left hand side, we can write it as sin squared x minus sin squared alpha equals 0. Now can we write it like this? 1 times sin squared of x minus sin squared of alpha, all of that is equal to 0. And then in place of 1, I am going to use the Pythagorean identity, which is actually sin squared theta plus cosine squared theta equals 1. So in place of that 1, I am going to write sin squared alpha plus cosine squared alpha. That is essentially 1. That's the Pythagorean identity of trigonometric ratios. So then times we have sin squared of x. So just in place of 1, I have written sin squared alpha plus cosine squared alpha. And then I am just writing down everything else as is. And let's remove the parenthesis. We are going to get sin squared of x times sin squared of alpha plus sin squared of x times cosine squared of alpha minus sin squared of alpha. All of that is equal to 0. And from here, can we write it like this? And in the next step, I am going to take sin squared of alpha as a common factor out of the second and the third term. So we can write it as, and then whatever we have inside the parenthesis 1 minus sin squared of x, I am going to use cosine squared of x in place of that. That is from that same Pythagorean identity. So we can write it as sin squared of x times cosine squared of alpha minus sin squared of alpha times cosine squared of x equals 0. Just in place of 1 minus sin squared x, I have used cosine squared of x. That's from the Pythagorean identity. And from here, let's just rearrange it a little bit. And now if we factor them, it's looking like a squared minus b squared form. So it would be a plus b times a minus b. And then you can clearly see that the first factor is nothing but sine of x plus alpha. And the second factor is sine of x minus alpha. And then from here we can say, well, then definitely sine of x plus alpha is equal to 0, or sine of x minus alpha is equal to 0. And then we already know that when the sine ratio of an angle is equal to 0, then the general solution for that angle would be n times pi, where n is an integer. So we can say that x plus alpha is equal to n times pi, or x minus alpha is equal to n times pi. And from the first one, what we get x equals n pi minus alpha, and from the second one we are going to get x equals n pi plus alpha. So in general we can see that x can be written as n pi plus or minus alpha, and that is the general solution, where of course n is an integer. So let me make a note of that. So this is the general solution for that particular trigonometric equation, which was sine squared of x equals sine squared of alpha, or even cosine squared of x equals cosine squared of alpha. So this is the general solution for both of those equations. So let me make a quick note here on the side that this is the general solution for sine squared of x is equal to sine squared of alpha, and also cosine squared of x is equal to cosine squared of alpha. And if we want to take an example, let's suppose we have an example like this. Sine squared of theta equals 1/2. Can we write it as 1 over square root of 2 whole squared? And then can we write it as square of sine of pi over 4? That is actually sine 45 degrees, or sine of pi over 4. So you can say this is actually sine squared of pi over 4. Now you see we can use sine squared of pi over 4 as the alpha angle, and then we can easily say that the general solution here will be like this. Theta, which is the unknown angle, will be equal to n times pi plus or minus pi over 4, where of course n is an integer. And that is the solution of this example trigonometric equation, where sine squared theta was 1/2. I hope everything made sense. Thank you for watching. See you in the next video.